Welcome to today's webinar, How to Strengthen Threat Hunting with DPI Sensors. Thank you for joining us and taking time out of your busy schedules. Today's webinar is brought to you by the Cosmos division of ENIA, specializing in deep packet inspection technologies. My name is Holger Schulze. I'm the founder and CEO of Cybersecurity Insiders, the online community for cybersecurity professionals, and I'll be your moderator today. Now it is my pleasure to welcome our featured presenters. First, I'd like to welcome Eric Larsson. Eric is Senior Vice President of Marketing at ENIA. Welcome, Eric.
Thank you.
Next, I'd like to welcome Sébastien Sinaud. And Sébastien is Product Manager for the Cosmos Probe. Welcome, Sébastien.
Thank you, Holger.
Excellent. Thank you both for presenting today. Now, let's take a quick look at today's agenda. First, we'll review the key findings of the recent research report on deep packet inspection for threat hunting, produced by Cybersecurity Insiders and commissioned by ENIA. After reviewing the state of deep packet inspection for threat hunting, we will dive deeper into some examples and how to implement deep packet inspection. But before we get started, let's talk a little bit about what is deep packet inspection and what is that research report that I mentioned just a minute ago. Deep packet inspection, or DPI, is a key technology frequently used in cybersecurity applications. DPI is embedded in products such as next generation firewalls, UTMs, secure gateways, and various threat analysis tools. DPI sensors in particular represent a new way of leveraging DPI. They strengthen an existing security tech stack inside high-end SOCs, security operation centers, and they do that with detailed traffic intelligence, and thereby they significantly improve threat hunting for even the most advanced attacks. All right, let's look more closely and dive into the key findings of the DPI survey we conducted, among security professionals during the summer of 2018. And one of the first questions we asked in the survey was, do you have a threat hunting team? Very simple question, right? And as cybersecurity threats, have become more prevalent and more sophisticated, many organizations are creating dedicated threat hunting teams that use, tools and tactics, including advanced analytics, to proactively find and address threats and vulnerabilities. And the results to these questions are quite evenly split, right? Half of the survey respondents said their organization already has a threat hunting team in place, while the other half says, they don't. Eric, on this data point, let me ask you this. Is having a dedicated threat hunting team a requirement for threat hunting success?
Well, I think it's something we see more and more. And when we say hunting team, sometimes it might just be one or two expert analysts because you need some good expertise to do this. But this is a good question to start out with, because in this webinar, we are looking at one of the tools, or should I say weapons, that can be used for threat hunting, and that's a DPI sensor. So threat hunting is becoming increasingly common to protect organizations against the most advanced threats. However, that proactive threat hunting that you mentioned, it requires advanced equipment and it requires expert skills. So I expect it to be part only of the largest SOCs, like those operated by high-end MSSPs or managed detection and response service providers, MDR providers.
Thank you, Eric. That makes perfect sense. And you mentioned technologies, and on that line, we asked our survey participants, which technologies do you use for cyber threat hunting? And about 1/4 of respondents ranked security information and event management software, SIEM in short, as the most important tool for threat hunting. Other key technologies that were mentioned include, next generation firewalls, intrusion detection and intrusion prevention systems, and DPI sensors, all grouped very closely together in terms of response rates. Eric, let me ask you this. What are your thoughts when looking at this ranking of technologies? Do you see any surprises?
Well, not really. As you know, SIM tools are key for SOC analysts because they provide the real-time analysis of all the security alerts based on logs from applications, logs from network equipment. So SIM are natural focal point for security teams. And I think this will remain true even with the evolution that we're seeing towards next generation SIM and threat analytic platforms, which add more advanced analytics and even user entity and behavior analytics, UABA, to some kind of unified security platform. So no surprise that SIM is the most used system for threat hunting. Now, it's interesting to see that DPI sensors are also considered an important technology. So I think a reason for that is that what's unique with the DPI sensor is that it extracts information directly from network traffic. So what you get is a factual, independent, and accurate picture of network activity. You cannot fake it here. Data is moving on the network, and you can see it with a DPI sensor. And since the DPI sensor captures all traffic, it's a good source of high-resolution information for forensics or threat hunting, because you can store all that information in the database. And we'll see in the second part of this webinar how that's done. And of course, it can tap the traffic at different parts of the network, inside the network, especially at different points, even between VMs, and we'll see some of that later. So, yeah, it's not too surprising, but I'm pleased to see that people are thinking of DPI sensors.
Exactly. Thank you, Eric. And on that note, you mentioned data and data analysis. We actually asked our audience about their biggest, data-related challenges when it comes to threat hunting, and easily the most common data-related challenge organizations face is a lack of resources, right, to analyze the collected data, which I think also implies somewhat of a lack of effective automation tools, right, to analyze data, and that lack of resources to analyze has been cited by about 2/3 of the respondents. So it's a significant result here. Other challenges noted, are that existing information is not precise enough. Right, that makes sense. That there's too much data related to threat hunting, right? Too much data overload and perhaps false positives, and also that there's often not enough good data, quality data. On that note, Eric, why do you think data and data analysis is still such a big challenge for threat hunters?
Yeah, well, there's a lot of data out there, and as you know, it's notoriously difficult to tune security tools so that they generate relevant alerts, but at the same time, you don't get too many false positives. So this is, of course, where machine learning comes into the picture. And the DPI sensor actually has a role to play here because it provides traffic information which can significantly improve that machine learning. So in this case, more information can actually be good, since machine learning doesn't require additional manpower, and machine learning thrives on large quantity of information because more information actually means better accuracy. So it'll be interesting to see how the market develops here, but we'll give you a couple of examples of that later on in the second half of the webinar.
Thank you, Eric. Next, we asked, how familiar cybersecurity professionals generally are with deep packet inspection sensors or probes. And it looks like a majority of over 6 out of 10 are at least somewhat familiar with DPI. Eric, does this come as a surprise, that many people are already familiar with DPI and familiar with DPI in the context of threat hunting?
Yeah, it's interesting to see that we have 2/3 of respondents saying that they're familiar with the DPI sensors because they're not installed everywhere. And like you said before, typically security professionals know DPI because the technology is already used in next generation firewalls, UTMs, secure gateways, etc. However, what's different here is those existing products, like a firewall, for example, are typically deployed at the edge of a network. And that means that they don't have that visibility. They don't always have visibility on internal traffic. DPI sensors, and you can install those anywhere in the network. You can have dozens or even hundreds of instances of these DPI sensors. They can provide that traffic visibility anywhere inside the network and even between virtual machines. So I'm pleasantly surprised that people know about the sensors, and it'll be interesting to see how the market develops here.
Thank you, Eric. Now let's take a closer look and move from the awareness of DPI sensors that we just saw and move to the actual use of DPI sensors for threat hunting. And it turns out about 1/3 of the organizations we surveyed are already using DPI sensors to strengthen cyber threat hunting. Another 45% are planning to use DPI sensors in the future. Eric, what does this data tell you?
Well, it's interesting here again to see that many people are planning to use more DPI sensors in the future. So there is a real interest for this type of technology. And I think it has a lot to do with the fact that the sensor can monitor all the traffic, and it can be used either as an independent investigation tool or to feed a security analytics solution. Now, I think some security analysts already use DPI sensors as add-ons to their next-gen SIM platforms or existing SIM. There are some basic type of sensors provided by people like IBM QRadar and Splunk and Logarithm. So that's probably a sort of first level that people are using today. But a standalone, more powerful sensor could also be a good tool, especially for threat hunting. So it seems like the response to this question confirms an increased interest in general for DPI sensors.
Exactly. Thank you, Eric. Next, we dug a little deeper to find out why organizations are using, or considering to use DPI sensors. And the survey shows that organizations are using DPI sensors for a wide array of objectives. Number one being to improve, network data visibility and depth of analysis. Eric, how would you interpret this finding as to, why people use DPI sensors?
Yeah, so that's a big and interesting question. So just to summarize how a DPI sensor works, it actually passively captures packets, it detects applications, it parses protocols, and then it can send metadata, for example, to behavioral analytics platform. And the information from the DPI sensor is what can improve accuracy of analytics, because each additional attribute, like a traffic attribute, greatly improves the machine learning accuracy. So this is one of the main reasons to use a DPI sensor. You get shorter time to detection, more accurate alerts, and less false positives. Now, the same DPI sensor can also be used for proactive threat hunting or to streamline forensics investigations, as we'll see later in the presentation. I see here that some people in this question have answered that they could use DPI sensors to strengthen IPS-IDS rules. And that's also an interesting point, because compared to an IDS, a DPI sensor is not rule-based. There's no alerts or alarms just coming out of the basic function of the DPI sensor. And if you take the case of forensics, the sensor is a drill-down tool used to uncover non-standard threats. And as an added benefit, you can use the intelligence from the sensor to strengthen IDS with some custom rules. So there is some interaction between IDS and sensors, but there's actually two different types of tools.
Now, as a follow-up question, we asked our survey participants, which cyber threats they believe DPI can help mitigate. And it looks like advanced persistent threats take the lion's share here with 50% of the response. Eric, do you see any surprises here?
No, I'm not surprised, because the DPI sensor is a powerful tool. So in the answer to this, we had a bunch of other things people also thought a DPI sensor could help with, but we decided to simplify it just to show APT is by far the type of threat that you would use a DPI sensor for. So either through this automatically feeding machine learning, or as a tool used by skilled experts for forensics threat hunting. And typically you use this when your standard tools are not sufficient. And in terms of threats, a DPI sensor can be used to expose the tricky things like, even zero-day attacks and advanced threats like data exfiltration, spear phishing, botnets and botnet beaconing, lateral movement. You can see suspicious file transfers. You could see SSL certificate violations, protocol obfuscation, you name it. Well, we'll see some examples later using a visual interface.
Excellent. Looking forward to that.
No surprises here.
Very good. Now, finally, we asked cyber, security professionals what information they need to store, right, for forensics or other analysis purposes. And at the top of the list is, our logs, cited by 89% of the respondents. And the next common, type of data are traffic metadata, URLs, email sender, file names, etc., mentioned by 85% of our audience, followed by full packet capture. Eric, it looks like we need to consider, a lot of data sources for analysis. What role do DPI sensors play here?
Yeah, this is actually a nice result, because it shows we had a qualified audience who understands the complementarity between these. You do need the logs, but you also need traffic data, and you need full packets for all the details during a short time window. So these are actually complementary. And if you just compare, for example, full packets, it's great, but typically limited to a small time window because of the high cost of storing all the traffic. Compared to that, the DPI sensor provides high information resolution, but at a fraction of the storage compared to full packets. Since the sensor information is based on traffic metadata, like you said, sender, receiver, device type, file type, etc. And you'll see some examples later in the demo. And in addition, some content can actually be discarded. So for example, video content, which represents huge volumes, can be discarded, or you can just decide to filter it out with your DPI sensor. and that makes DPI sensor even more efficient. So we've seen cases where the size of forensic data can actually be reduced 150 times compared to full packet. So I would say these are the three sources that you need, and they nicely complement each other.
Okay, now that we looked at the key reasons and considerations for both DPI sensors and threat hunting, Eric, can you and Sébastien give us some examples and implementation details?
Sure. So let me just introduce the case study here and hand it over to Sébastien. So there's a case study where one of our customers has there's a large security operations center in the EMEA region, and you see in principle the type of tools he has. And the problem they had is, first of all, the SIM does not provide sufficient information when they need to do the forensics investigation. And then the full packet, of course, can only retain a short period of time of traffic. And then it's a little bit cumbersome to parse all the data. But I'll hand over to Sébastien, who will take us into some more detail.
Yes, thank you, Eric. So yes, indeed, actually, in this use case, there was already a SIM in place fed by various network equipment like firewall, proxy, IDS, and logs from switches and routers. Also, a full packet capture solution was in place, but on one hand, the SIM does not provide sufficient information for forensic investigation, and the full packet capture can only retain a short period of time of traffic. And extracting selective data from this equipment is a long and complex operation, mainly due to the poor indexation of this very large data. So DPI sensor has been deployed to feed an existing data lake with network traffic information. And custom dashboard has been developed to easily drill down for a global view of the network to a very detailed view of each and every flow of the network. So DPI sensor data were also used to feed behavioral analytics containing machine learning capabilities to be able to alert on significant variation of the network traffic.
And just one comment here. So that you're going to focus on this piece, and then there's a second way of using them, which
absolutely, yes.
Also for forensics and threat.
DPI sensor were really used for two different use cases. But first, let me show you where the DPI sensor were located on their network. So in the data center, there was already a next generation firewall at the internet gateway, providing already some visibility on the traffic between the internal network and the internet. And IDS and web proxy also provide information on internet access. So on that part, on the network, I would say there was sufficient data. But however, the SOC was completely blind regarding the internal traffic, like client to hosted server or VM to VM traffic. And this traffic is very important to detect insider threats and lateral movements resulting from any malware activity. So here, as you can see, a DPI sensor plugged on the span port of an internal switch provides visibility on internal traffic. This means that you can see malware activity such as lateral movements between two internal machines.
Right, which is the kind of things you can't see when your equipment is here at the edges. And
absolutely. Here, DPI sensors are working as agents on compute nodes, providing visibility on inter-VM traffic, where there could also be malware activity or shadow IT that must be detected. So for those who are interested in technical details, the DPI is able to access traffic into the compute node using different methods. On OpenStack, third-as-a-service capabilities provided by Neutron allow to duplicate traffic from one or more VM into the sensor. And on VMware infrastructure, a promiscuous mode can be configured on distributed virtual switch to gain full visibility on all traffic crossing those virtual switches.
Okay, so this is the famous east-west traffic.
Absolutely.
VMs.
And some of this traffic just stay on the compute node. It does not cross any physical equipment.
Right, so it's actually down here.
But let's focus on this first use case of the DPI sensor where feeding a machine learning component. Because the abundance and richness of traffic metadata provided by a DPI sensor make it a perfect feed for behavioral analysis. Traditional behavioral analysis concentrates on volumes of data exchange between the devices, but without any visibility on the nature of the exchange data. So weak signals from stealth malware cannot be detected with such approach. So with this additional data feed, the analytics engine is able to detect variations on characteristics of the traffic and not only on volumes.
Well, yeah, what does this look like, this famous metadata?
Yeah, so indeed, so a DPI sensor main capability is to extract metadata from any level of the protocol stack. So from low-level protocols like MAC addresses, IP addresses, or port number, replacing traditional NetFlow-like records that you can get from switches or routers. But on top of this data, DPI sensor can classify all layers above the transport protocol up to the application level. So for instance, you can extract any metadata from HTTP, obviously, URL, content type, user agent, response code, whatever, and also metadata from the application on top of HTTP, where you can find things like product name or version numbers. On webmails, you will have email addresses, subject, you will have login information also that you can only access if you have layer 7 visibility on your network.
Okay, so all this stuff is what you feed into the machine learning, and I get to an additional source of information.
Yeah.
And that sharpens the results of machine learning.
Yes, because the main principle of behavioral analysis is that you get an engine learning from normal network activity, and then you can detect variation from this baseline. And if you have a DPI sensor, then the baseline is not only based on volumes, but also on a large set of metadata. So for instance, you can see which applications are hosted on each and every server of your network, or what are the devices that are connected on the network and what are their characteristics, like device type, device version, operating system version, for instance, that you can get. And also you can see what port numbers are open on your network and what are their purpose.
Mm. Okay, so here's some examples, right?
Yeah, so let's take some of the example of things we can detect with such approach. For instance, shadow IP detection. If you have a new device connected on the network, and when we say new device, is new network profile, something new on the network, that can be detected with such approach. Same thing if you get new protocols suddenly appearing on a device, like if you have crypto mining, or if there's a dark web access, for instance. Such approach can detect that quite easily. Also for lateral movement detection, if you get unusual variation of traffic between two devices with new protocols, like trying NFS or SMB access, for instance, between two machines, that's probably the result of a lateral movement attempt. Mm-hmm. Same thing if you get a port number at L4 level that is used by the new protocol, is probably also a malware trying to scan your network and see an open port and try to connect with any kind of protocols. So if you don't have this layer 7 visibility, you cannot detect such movements on your network.
Right, so it's the scanning that you see and the testing of the different protocols.
You see the testing, yeah. And to check that it's a test on a forbidden protocol, you need to know which protocol it is. So you need to have DPI there. The volumes are not sufficient.
Yeah.
Same thing for intrusion attempt. You can detect much more advanced intrusion attempt by looking if there's failed connection for some of the protocols, some SSH access or LDAP access. You need to know actually that there's failed connection to detect such intrusion attempt. Same thing if you get obsolete protocol on your network that are not supposed to run on the data center, then it's also an alert that something wrong is going on your network actually.
Right. So it doesn't replace other sophisticated tools for behavior analysis, but it does make the machine learning richer because there's more info now feeding it.
Exactly. So now let's take a look at the second use case where the SOC is using the DPI sensor for forensics investigation. So in this case, the DPI sensor is sending detailed information in JSON format from each flow seen on the network to a large open source time series database. So this allows to easily search into several months of connection history based on a large set of criteria, those famous metadata. So the protocol name, application name, email sender, SSL certificate details, of all these kinds of metadata. You can query actually all the flow matching those criteria. And this helps a lot the analyst to check if an alert received for another tool like an IDS is actually a false positive or not. For instance, if an IDS reports that there's on port 53, there's a packet which is not DNS. So that's typically what the DNS can do. And we'll report that to the CM. Then an analyst can query this database and extract all the non-DNS flow on port 53 from the last couple of weeks, for instance. So then the analyst can have details about those flow and looking at from which machine it's coming from and what is actually the actual protocol encapsulation. And usually you can see peer-to-peer traffic, for instance, trying to use that port to do this forbidden activity. So then identification of the machine owner can be done also, and then you can remind the owner that peer-to-peer is not allowed in the company, for instance.
So in this example, it starts from an alert from the SIM, and then based on that information, you drill down with the DPI sensor and this visual interface.
And then you can investigate on this alert.
Okay.
So let's see a few dashboards that have been built specifically for this customer. So here the dashboards are made by the analyst itself using an open source visualization tool. And here we see a graph at the top that is showing the overall bandwidth consumption on the network, split by application. On the bottom left, you have a table showing the total volumes and number of packets for each application per IP address. And on the bottom right, you see the total volumes and number of packets also per IP address, but split per full protocol encapsulation. So with such dashboard, analysts can easily see all the application used on the network or on a given subnetwork. And by whitelisting the expecting application, the dashboard will only report the applications that are not expecting on the network. And then you can see in a glance what is new on this network. And same thing for the protocol encapsulation. You can check if all your traffic is properly encrypted with a secure layer. If you see, for instance, an SSL layer in the middle of the protocol encapsulation. You can also see and check your tunneling. If all the tunneling are supposed to be here, if you get a VLAN or MPLS or layer on your network, is that normal or not? So in a glance, you can create rules defining how your traffic is supposed to be encapsulated, and any variation can be easily seen with just dashboard.
Okay, it's interesting to see all the layers of encapsulation here. How far can you go as far as how many layers of encapsulation?
Yeah. So it's not limited, but usually I can have 10. Yeah. It's probably kind of maximum 10 different layers, but we don't have specific limitation.
No limitation.
Yeah.
Okay, thank you.
So then from that, you can actually, if you detect, the analyst detects an anomaly, it can drill down with a single click and focus on a specific application or on a specific protocol encapsulation to investigate deeper on it. So here you can easily see for a given application which are the clients generating the traffic. So they can be maybe disconnected from the network for remediation if it's a forbidden traffic, or also which servers are impacted by the traffic, because those servers might be infected and remediation might be needed.
Okay.
So if you need to take a remediation action, you can still drill down again and for a given server and a given service, see what's the history of this service. So here's the example of LDAP server, Active Directory server. If you need to reinstall it because it might be infected, you need to know actually which are the clients who have used it during the last weeks, because that might be impacted by your remediation operation. So in order to minimize the impact of the remediation on your network, this visibility is quite very useful for analysts and IT operations team.
Right. So if you want to shut down a client here, you can tell them ahead of time.
Yeah.
So they know it's not going to have an impact on.
You can predict who's going to shout when you're going to.
Who's going to scream? Yeah.
So this is another example of dashboard. So this one is listing all the port number used for each application, sorted by traffic volumes. So for instance, you see that DNS is on port 53, which is quite expected, on HTTPS. On port 443, you got HTTPS. So here you got actually normal activity. And you can, exclude this normal usage from your dashboard. For instance, using the YANA standards that defines port number per application. And then every time you get an application which is not what is supposed to run on this port, you can immediately detect that. So it's another way also to see abnormal activity proactively.
In this particular case, it looks normal, but you, like you say, you can just filter out the normal if you want to focus on anomalies.
So now a bit similarly, the DPI sensor can also be used for threat hunting, because when an anomaly is detected thanks to this flow classification, you might want to get very detailed information for a given server. For instance, you might want very detailed information for one given server or very detailed information for one application across all your servers. So to do that, you need to be able to dynamically change the configuration of the probe. And that can be done because the DPI sensor provides a centralized console when you can create rules or what do you want to extract or not on the full data center. So this kind of request for more detailed investigation can be done in a few clicks using the decentralized console.
Okay.
So here the same dashboard as we've seen previously can be used to detect peak of traffic. So here we can see a peak of HTTP traffic due to Windows update actually. So it might show or highlight an attack, and you may want to check on the server exactly what's happening. So you can configure the DPI sensor to extract all detailed information and every transaction for that specific server. And then the result of that is that you can create a dashboard listing very detailed information from each and every HTTP transaction, for instance. So in this dashboard, you see that requests and responses are correlated together into a single row, showing information such as HTTP method sent by a client, URI, user agent, server name, response code for the server, even response time for a server. That's also showing the quality and the service is delivered normally, and the number of identical requests during a given time interval, and also the total number of transfer bytes. And this very detailed dashboard can be made of a large number of protocols, like audio and video protocols, industrial control system protocols, emails, file transfer, peer-to-peer. And actually, there's 3,000 different protocols and applications detected by the DPI sensor, extracting more than 5,000 metadata. So the possibilities of such specific dashboard are almost unlimited.
Yeah, this is just a quick example, but of course, when you're an expert, you know your own network, you know the behavior, you know what to look. This becomes a very powerful tool because you configure it according to your needs. So let me wrap up with the key takeaways here. First thing is, what is a DPI sensor? As you've seen, the DPI sensor is a passive monitoring function which provides detailed network-wide visibility. It's used to improve threat analytics, and it's used for forensics and threat hunting. Second, how can a DPI sensor strengthen analytics then? Well, as you've seen, the information extracted from traffic flows in the form of metadata can boost machine learning, and that improves detection and alert accuracy. And finally, how is a DPI sensor used for forensics and threat hunting? Well, it is an expert tool, so you can use it to streamline investigation, and typically it shortens time to detection. So if you want to know more, you've seen there's a couple of documents attached to this GoToWebinar. One is the report, the survey findings. You can just download that. Another thing is a data sheet on the Cosmos probe, which is a DPI sensor. Then you can also connect directly to the website. So it's cosmos.com, then you see the URL here, or you can just navigate the cosmos.com website to see more about Cosmos technology and the DPI sensor in particular. So Holger, I think it's time for questions.
Yes, exactly. Thank you, Eric. And thank you, Sebastian. Excellent presentation telling us about the DPI sensor. All right, let's see. Eric, the first question is, how does a DPI sensor handle encrypted traffic?
Yeah, that's a good question. Well, it turns out in many cases, the traffic is not encrypted because an SSL proxy is installed especially on the internal network, which it monitors. And this means that the traffic is clear, and the DPI sensor can classify all the traffic and extract all the metadata. Now, in case the traffic is encrypted, there's still ways to classify the traffic. The DPI sensor in that case will not extract metadata, but it can still classify. For example, Sebastian, in the case of HTTPS, I think we look at the name in the certificate.
Yeah, so during the handshake, SSL handshake, there's a SNI sent by the client, usually providing information about the service it's right to access, and also on the server side, when the certificate is downloaded for the server, analyzing the certificate and the command name is also very useful information to classify the service.
So that's typically applications like Google, Facebook, WhatsApp, and the classification in this case is 100% accurate because it's based on that information which is in clear during the handshake. Now, of course, then there's the case of proprietary encryption, like peer-to-peer, BitTorrent, etc. And in that case, we'll use a statistical model to identify the protocols. And what kind of accuracy do we get on that usually?
Yeah, it's quite accurate because this peer-to-peer, for instance, acquire generic patterns in terms of size of packets or sequences from logging or for finding actually the right piece of files to download. So accuracy is more than 90% using such approach.
Right. And then finally, there is another method, which is you could also look at DNS queries to identify types of traffic.
Yeah, because usually before an encrypted session is established, there's a host name resolution before, so destination IP needs to be resolved from the host name, and correlating this host name with the subsequent connections is also useful information for classification.
Right, but once again, in most cases, especially in internal traffic, controlled networks, the traffic isn't clear. So in that case, the DPI sensor works on clear traffic, both for classification and metadata extraction. That's the answer, Holger.
Excellent. Thank you, Eric. Thank you, Sebastian. The next question, why would I need a DPI sensor if I already have an IDS, intrusion detection system?
Yeah, sometimes we get asked that question, and I already alluded to that in my part. So unlike an IDS, a DPI sensor is not rule-based. There's no alarms, no alerts. And the DPI sensor just acts as an additional feed for machine learning and as a tool for threat hunting and investigations. But there is a connection to the IDS, because we've seen some people actually use the information they can get by using the DPI sensor to then tune their IDS with some custom rules.
Absolutely. And also, as its name states, an IDS is here for detection, not for full classification. So an IDS will detect there's some Skype on your network, but will never be able to classify all the flow. So for machine learning algorithm, it's clearly a missing information here.
Right.
Very good. The next question, what else could you use a DPI sensor for? For example, troubleshooting?
Yeah, that's a good point. Because, of course, when you have these DPI sensors connected, you can look at traffic in your network. So why not use them for something else? So what we've seen is people use them also for troubleshooting, for actually looking at bandwidth issues, quality of service, performance problems. They can also be used to check compliance. For example, if you have exposed personally identifiable information, or maybe plain text passwords, or you can see some outdated protocols. So some SOCs take advantage of the installed DPI sensors to also look at these areas.
The next question, how do you manage a large number of sensor instances?
Yeah, that's a good one. I'll let Sebastian answer, because we've seen people install many of these. They're just software.
That's a very good question, because if you want to really see 100% of your internet traffic on a large data center, you might have a large number of instances, hundreds, sometimes thousands instances of very small probes. And to manage this cluster, you do need a centralized management console. This is mandatory. First, to check the health of the sensor, to modify the level of extraction that we see before for threat hunting, or just to manage software updates. So Cosmos Probe is embedding INIA element on device manager, to provide such capabilities. So we provide a simple API available in netconf or REST, or just as a CLI that allows the operator to run commands on a single sensor, or to all the sensor, or a part of the sensor.
Right.
And that's definitely mandatory for this use case.
Okay.
Very good. The next question, what is the performance impact of having these sensors running on a network?
You mean how many CPUs, how much RAM, I suppose? Sebastian?
Yeah, so typically the resource impact is around, you need one CPU core and 4 gigabytes of memory to fully analyze 1 gigabit per second of network traffic. So usually allocating one core to a sensor on each compute node is sufficient and is usually acceptable from data center to allocate for having such capabilities.
Right. So what we've seen, one core, 4 gigs of RAM for 1 gig of traffic seems to be the sort of average, and that seems acceptable.
Yeah.
All right.
All right, looks like we have time for one more question, and the question is, what is the usual retention time for DPI data?
Yes, that's a good one as well, because usually you may want long retention time, but what usually our customers are doing is they store weeks of data with 1 minute granularity. So with very, very detailed information and very granular. And the space to do that is usually 150 times smaller than what a full packet capture would require. But then if you want to improve again the retention time, you can reduce this granularity and having it per hours or per days possibly. And then you can keep information for years.
Mm-hmm. Right, so it is a good complement to full packet, and full packet will by definition give you the whole traffic, but is expensive in terms of storage and can be cumbersome to search through. Here you have good information resolution, but over a much longer period of time. So between those two, you have a pretty good picture of what went on, what's been going on in your network if you need to go back. Okay, well, thanks. Back to you, Holger.
Thanks, Holger.
Excellent. All right. With that, we are at the finish line for today's session. Now, as we're closing this webinar, I would like to thank you all for joining us. I hope you enjoyed today's presentation. I would also like to thank Eric and Sébastien. Many thanks for sharing your insights on deep packet inspection and how to use the technology for more effective threat hunting. Thank you both.
Thank you.
Thank you.
Now, this concludes today's session. I hope we will see all of you again at one of our future webinars. Thanks, everyone. Have a great day.